Dear students, welcome to the lecture series on the topic engineering graphics. So today we are going to discuss about dimensioning in engineering graphics. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now the principles of dimensioning, they are governed by standards for engineering drawing. So the standards, they are the set of rules that govern how technical drawings they are represented. Therefore, the dimensioning principles, once again, they will be uniform all across the world so that there is no ambiguity between the construction as well as the reading of the engineering drawings. So here the dimensioning refers to act of giving dimensions to the technical drawing. So here we have a technical drawing over here, and we can see that the dimensions which are mentioned onto the engineering drawing, they facilitate error-free manufacturing of the engineering constructions and the components, since the proper representation of the dimensions onto the engineering drawing will facilitate appropriate understanding of the shape and size of the given engineering component or the engineering construction. So once again we can see that in India we have BIS SP 46 standards, and these standards, they govern the dimensioning which is to be done onto the engineering drawing or the technical drawing. So we have IS 11669 1986 fundamental standard for the dimensioning, which are covered by BIS SP 46 2003 standard for the engineering drawing. So we can see over here that whenever we have any given technical drawing, so we are going to make use of different types of lines. You can see here we have the extension line, here we have the dimension line, then we have the leader line. So different types of the lines will be used to describe the shapes and sizes of the engineering components or the engineering fabrications and the construction. Similarly, besides using different types of lines, we also require lettering, that is numerals will be required, different manufacturing instructions will be required, and different types of the symbols. You can see here we have put down the symbol regarding the diameter of the circle. It can be any of the symbols which we can use, symbol for the radius of the curve. So wherever the radius is there for any given component, part of the component, so we have to mention the radii. So we have to use different types of the symbols, or even the notes and conventions have to be used to facilitate error-free manufacturing. So the notes are added onto the engineering drawing with the help of the leader lines over here. So these notes, they will facilitate easy understanding of the manufacturing requirements which are associated with different components which are to be manufactured. So this way the dimensioning is going to facilitate the description of the size, location and specifications of the object, because no technical drawing is complete without the dimensioning, right? So you can get the shape of the component if you do not carry out the dimensioning, but the accurate manufacturing of any given component will be described only through the appropriate dimensioning principles which have to be followed while the development of any given technical drawing. Now, dimensioning principles, they are governed by Bureau of Indian Standards and BIS SP 46 2003. It defines dimension as a numerical value which is expressed in appropriate units of measurement, and it is indicated graphically onto the technical drawing with the help of different types of lines, symbols and notes. So this way we can see that any dimensioning will be complete when we are using different types of lines, different types of symbols and different types of notes. They are required to complete dimensioning of any given object over there. Then dimensioning, it means indicating the size of the object and other details essential for its construction, manufacturing and functioning using lines, numerals, symbols, notes, etc. onto the drawing. So there are different important aspects of the dimensioning which we need to remember. The first and foremost is the units of measurement, because with every dimension we are not going to put down the units of measurement. So in the title block of the drawing we will be putting down the unit of measurement. So all the numeral values which are added onto the technical drawing, they will be corresponding to that particular unit of measurement. So most commonly used unit of measurement is the millimeter, but especially for the civil engineering drawings and the architectural drawings which are dealing with larger sizes of the objects, so there we can even use inches or feet or even meters over there. So different units we can use, but whichever unit you are using, we have to mention the unit of measurement into our title block. And if we have to show the measurements for the angles, so the measurements for the angles will be shown in degrees. Similarly, whatever symbols are required, so the symbols, they have to be incorporated onto the technical drawings to indicate the specific geometry wherever required. Let us say we have to draw a circular segment. So in order to draw a circular hole over there, we have to show the symbol of phi. Similarly, some arc or radius is there, we can put down the symbol of r. Let us say we have to manufacture a square component. In order to manufacture a square component, we can put down the symbol square and write down 40 next to it. So square symbol 40 will mean that the size of the component is 40 and the shape of the component happens to be square shape, or even we can write down SQ40 over there. So SQ also means that this is a square shaped component. Similarly, different types of notes are also added onto the technical drawings to provide information related to the special manufacturing considerations which will be required to complete the construction or manufacturing of the given engineering object. So we can divide the dimensioning into two different parts. The first one is the size dimension. In the size dimension, we are going to label, you can see over here, the external lengths and breadths and heights of the component over there. So we can define the external dimensions of the object using the size dimension. So in this type of the dimension, the external size of the object is represented, which will be showing the length, breadth and height. So you can see length, breadth and height we can show using the size dimension. Whereas if we have to carry out the manufacturing of this object, then the location of each and every section or the segment of the component has to be described appropriately. So there we need to describe different dimensions which may be from any given surface. So I need to mention dimension of these holes from the surface. I need to mention the distances between different holes over there. So we need to describe shape and characteristics of each and every sub-segment of this particular component. So in the location dimensioning, because the name is location, so we have to fix location of each and every sub-segment of this particular component. You can see if I have to draw this arc, so I have to fix the location of the center of this particular circular portion. Similarly, this is again a circular portion. I have to specify where my center of the arc or the radius of the arc will be starting. Similarly, I have to fix the distance of any given characteristic feature from the surface over there. So here we are going to show in this type of dimensioning the distances between different parts of the object and the distances between centers of the circles, they will be described. So here we can show the center to center distance, we can show the center to surface distance, or we can even show the surface to surface distance. So all these details of the components, they will be described using the location dimensioning, so that the appropriate and accurate manufacturing of the component can be completed. So let us talk about now the dimensioning terminology. As we have discussed that different types of lines, they are used to carry out dimensioning in any given technical drawing. The different types of the lines which are associated with providing dimensions onto the technical drawing, they are extension lines, second ones dimension lines, and the third ones, they are the leader lines. So the extension lines, they provide us the information regarding the start and end of any given dimension, that is the extent of the given dimension. Whereas the dimension line, again this is a thin line which is capped on either end, and it is having a break in between to represent the numeral value of the dimension. So they provide us the exact idea about size of any given dimension. Whereas the third types of lines, they are the leader lines. They provide us the information about any special requirements regarding manufacturing onto the drawing. So we have to draw an inclined line followed by the horizontal line. So here the special characteristics regarding manufacturing, maybe surface finish, maybe the hardening requirements, maybe any specific requirements of the manufacturing will be added onto the leader line. Now let us go through each one of these lines in details. So extension lines, they are the thin lines which are used to establish the extent of any given dimension. That is, they provide us an idea about starting point and the end point of any given dimension. And these lines, they will begin around 1.5 millimeter apart from the object line. Let us say if I have to describe the dimension of this object line, then I have to leave 1.5 millimeter from here, 1.5 millimeter from here, and then draw two thin lines to indicate that this dimension starts from this particular position and this dimension is going to end at this particular position. And these extension lines, they will extend to 3 millimeter beyond the last dimension. So wherever our last dimension is there onto the technical drawing, these extension lines, they will be extending 3 millimeter beyond the last dimension line onto any given engineering drawing. And another requirement for the extension lines is that these extension lines, they should not cross the dimension lines. Now the next type of lines which are used for dimensioning, they are called dimension lines. So as we have discussed, these are the thin lines which are capped on the either of the two ends with arrowheads. So these are the arrowheads, and they are broken along their length to provide a space for the dimensional numeral. So here we have the value or the size of the dimension. So these dimension lines, they are used and they are helpful to indicate the length and size of any given dimension. So in order to represent the size of any part of the drawing, so we have to use both the extension lines as well as the dimension lines. Next you have the leader lines. So leader line, it is a thin solid line which is used to indicate the feature with which a dimension or a note or a symbol will be required. So many a times we do not put down the dimensions within the object itself, within the image itself. So many a time we are putting down the dimensions even outside. When we are going to put the dimensions outside the image, when there are multiple segments which are requiring a similar treatment. So this is an object which is requiring two similar holes to be drilled through this particular component. So rather than mentioning this information twice regarding the size of this hole, so what we have done, we are going to mention this dimension only once, but then using this leader line. So leader line will be the one which is having a horizontal component and an inclined component followed by an arrow. So here the arrow will indicate where that note will be focused, and the horizontal component will be used to describe the shape or maybe the special manufacturing requirement which is associated with the given component or given part of the object. So here you can see we have got two holes to be manufactured. So what we have done, we have added a leader line over here indicating that two holes are to be drilled, and both of these holes are having the diameter, that is phi is equal to 20 millimeter. So by just providing one dimension over here, we are able to label both of these holes. Similarly, the leader lines, they are also used to indicate any specific manufacturing requirements of the components. So here the special manufacturing requirement regarding this hole is that this hole has to be case hardened heat treatment. That is, special hardening requirements are there with respect to this hole which are not applying to the other hole. So this way the leader lines, they will provide you with the data which will be required by the manufacturing people, so that the components, they can be manufactured with the utmost accuracy and reliability. So the data must be written horizontally onto the leader line. Here again you can see we have written down the data horizontally. So the horizontal line is used to provide the information which is specific to the given part of the object over there. Next one, let us start with the methods of the dimensioning. There are number of methods of the dimensioning which are used to put down the dimensions onto the technical drawing. So the first method is aligned dimensioning. So as the name suggests, aligned. So the horizontal dimensions, they are aligned with the horizontal part, whereas the vertical dimensions, they are aligned with the vertical side of the drawing. So in this type of the drawing, you have the dimensions which are placed perpendicular to the dimension line, so that they may be read from the bottom side or they will be read from the right hand side of the drawing sheet. So here you can see, if you have to write down these dimensions, you have to stand over here. Similarly, if you have to write down the vertical dimensions, so the person has to move in the perpendicular direction. He'll be going in this direction, and only then he'll be able to write the dimensions or the numeral values over here. So this type of aligned method is not usually recommended, because we will want that all the dimensions, they should be read from the same side, that is from where the observer is actually working on the drawing. The observer need not move to the other side to mention the dimensions onto the engineering drawing. So these dimensions, they are placed in the middle and top of the dimension line. Sometimes you can write them in the middle, or even you can write them on the top of the dimension line. Now the next type of the dimensioning system is the unidirectional system, which is well accepted all over the world. As we say, unidirectional, so person need not move to the other side to write down the dimension. So all the dimensions, they will be written down and they can be read from the same side, from the side where from the drawing is being prepared. So in the unidirectional system, the dimensions, they are placed in such a way that they can be read from the bottom edge of the drawing sheet. So from one side only you will be mentioning all the dimensions onto the drawing sheet, and they will be interpreted from the same side only. So all the horizontal dimensions, they are placed at the middle and on the top of the dimension line, while the vertical and inclined dimensions, they are inserted by breaking the dimension lines in the middle over here. So these are the two examples. You can see that all the dimensions, they can be read from one side only. So we can say that the drawings are dimensioned using an accepted set of standards, such as placing the dimension text such that it can be read from the bottom of the sheet. So this is the universally accepted method of dimensioning the technical drawing. Then there are number of other methods of putting down the dimensions onto the technical drawing. The first method is chain dimensioning. So these methods, they are usually used whenever we have the longer objects and we have to carry out the dimensions in the series. So the first method is chain, as the name suggests, chain. So here all the dimensions, they are aligned in such a way that an arrowhead of one dimension touches tip to tip with the arrowhead of the adjacent dimension. So whenever you have the objects which are longer in shape and then there are discontinuities within those objects, so we have to mention number of dimensions side by side. So what we have done in this case, chain means one after the other. So here all the horizontal dimensions are also mentioned one after the other. So end to end arrows, they are placed over there. Similarly, for the vertical dimensions as well, end-to-end arrows they have been placed to indicate the dimensions onto the technical drawing. Then the second method for putting down the dimensions in the series, it is called parallel dimensioning. So in the parallel dimensioning, you see, for the horizontal dimensions we have one datum, for the vertical dimensions similarly we have another datum. So this is the datum for vertical dimensions, this is datum for the horizontal dimension. So all the dimensions are shown from the common reference line. You see, whatever may be the dimension, we have to start from the zero datum over there. So all the horizontal dimensions, they will be starting from the zero value of the horizontal datum. Similarly, all the vertical dimensions, they will be starting from the zero for the vertical datum over here. So these dimensions, they share a common extension line. Just see, this is a common extension line. So this is common extension line for the vertical dimensions. This is the common extension line for the horizontal dimensions over there. So this method is adopted when the dimensions have to be established from a particular datum surface only. Then the third method is the combined dimensioning. Again, this is applied for the dimensions which are there in series. So there we are not using a particular either the chained or the other one. So here we are using both these methods parallelly. That is, when both the methods, that is chain dimensioning and parallel dimensioning, are used on the same drawing, then the method of dimensioning is called combined dimensioning. So this is not a very good method, but still it is used by certain practitioners in preparation of the technical drawing. Then another method which is again used for putting down the dimensions in series, it is called progressive dimensioning. So as the name is progressive, so we have a single datum. You see, datum is 0, first dimension is marked, and in this case the dimension line will have only one arrow. The first dimension is marked from this datum, it will be giving the reading as 40 millimeter. Then the second dimension, because it is progressive, so first 40 is stable, then another 30 means next dimension is 70 millimeter. So this distance of this center of the circle from the initial datum is 70. Then another one, again one arrow is added, and this distance will be 100. So the intermediate distances, if you have to work out, then you have to subtract the previous dimension from the current dimension. So in this method, a dot and a 0 is used to indicate the datum line, and the dimensions are indicated progressively from the datum. So any particular distance if you have to measure in this case, so this dimension minus this dimension will give you the distance between these two surfaces over there. Similarly, if the distance of final hole from this surface is required, so this will be 125 minus 100. So this is the distance, 25 millimeter is the distance between this surface and the center of this hole over there or the circle over there. Then the next method of dimensioning is coordinate dimensioning. So as the name indicates, coordinate. So here we have the 0, 0 datum over here. So most of the times if we are writing, you see so many dimensions, we are using the parallel dimensioning. So many dimension lines and extension lines will be required. So what we can do, rather than using so many dimension lines and the extension lines, we can use the coordinate system. So 1, 0, 0 we can define over here, and then I will give you the idea about the x and y coordinates of the 3 points, and these 3 points will give me the idea about x and y coordinates, and then the size of the hole I can indicate over here. So this way, no need to put so many dimensions onto the drawing. My drawing will remain simple. I'll just put some datum size over there, 0, 0. And then by putting down this extra information in the form of the table, I'll be able to locate the center of this hole, center of this hole, and center of this hole. And then the sizes, they are also mentioned onto the drawing. So I will use the rectilinear coordinate distances over there to mark the centers of these holes, and the sizes will indicate what are the operations which are to be carried out. So for simplicity, in the coordinate system, the dimensions can be shown separately in a tabular form. So this is used when the number of features they have to be located from the common origin. So my origin lies over here. So these dimensions need not be mentioned. I will straight away mark 0, 0 and then provide dimensions in the tabular form. So this is called coordinate dimensioning system. Now let us work out the principles of the dimensioning which have to be used in order to make appropriate dimensioning onto any given technical drawing. So for every solid, since a solid is having 3 dimensions, so each geometric shape making up of the solid must have a height, width and depth. So all these 3 components of the solid must be indicated onto the drawing using the dimensioning. So the overall dimension must be provided on the outermost portion, whereas the smaller dimensions, they should be located closer to the object. So please see here the multiple dimensions I have to mark over here. If I have to mark multiple dimension, smallest dimension should be closest to the object line, and as the dimensions they are increasing, so we have to mark them away from the object, and the largest dimension of the object will be mentioned at a farthest distance from the object over there. So smaller dimensions closer to the object. As the dimension size are increasing, so dimensions they will be moving away from the object, and the total size of the object has been mentioned as we have discussed. Then the next thing is each feature is dimensioned and positioned only once. So you must mention every dimension only once. No repeatability or redundancy should be there. Just see in this picture, in this drawing, I have mentioned the overall dimension. I have also mentioned the intermediate dimensions as well. So if the total dimension is 1.6 and this is 0.5 and this dimension is 0.6, so both of these dimensions they make for 1.1. So obviously this dimension is automatically 0.5. So either I should provide all 3 or I should provide total and the remainder 2 over there. So providing dimensions multiple times means redundancy is there. Similarly over here, so here you have total is 1.6, this is 0.6 and this is also 0.6. So automatically the remainder can be calculated. So I can mention 0.4 here, then this need not be mentioned. So accordingly we have to check that any one dimension is mentioned only once in any given technical drawing. So no repeatability. Similarly, dimensions and notations, they must be placed on a sketch where they can be clearly read and they can be clearly understood. So just see here we have the top view of the component. So on the top view of the component, if I am indicating this dimension, so even though it gives me an idea, okay, this is the size of the object, but it does not give me an idea about the shape of the object. So if I show this dimension over here, it means that now there is discontinuity, whereas this figure does not give me a clear idea that this is the size of the object, this is the part of the object which is having the larger thickness, whereas this is the part of the object which is having the lesser thickness. So we should provide the dimensions across those particular segments which provide us clear idea about shape and other desirable characteristics of the objects over there. Then the next one, the dimensions, they should be attached to the view where the shape is known the best. Just see another example, similar one. I have got this is my top view, this is my front view of the object. So in the front view, can I make out that this is a circular portion? No way. It may be a rectangular component where this hole has been made. But if I look at the top view of this component, this portion of the component is a circular one. If I add radius over here, but the drawing or the shape of the object does not describe that this is a circular component over there, so representing radius symbol over here would be inappropriate. So if I have to show the radius, so radius has to be shown where the shape of the radius is quite apparent over there. So this way we have to make sure that we are putting down the right dimensions at the right locations as well. So this is how you see the shape of the component is being reflected. It is being described by this radius over there. So this dimension is showing us the radius, and the shape is also commensurate with that. Here the rectangular shape does not describe the arc dimension to be indicated over here. Similarly, the related dimensions, they should be grouped and they should not be scattered wherever possible. Here you can check, these are all the dimensions but they are scattered. So I have to just do the clubbing and then find out this remainder dimension over here. So because this is shown somewhere else, this is shown somewhere else, and this dimension is shown somewhere else. If I show all of these three dimensions, because all these three dimensions, they are going to give me the length of this segment, length of this segment, and length of this segment. So I have to describe lengths of the three segments over here. But if I show them separately or scattered, then it will be giving me more trouble to identify this particular segment over there. Next one, we should keep the arrowheads slim and neat, and we should not dimension the hidden lines. So hidden lines are not to be dimensioned. So wherever possible, we should try to dimension these portions of the object where these were visible basically. So wherever, in whichever views these portions of the objects they are visible, we should be putting down the dimensions of these particular segments of the objects onto that particular segments of the drawing. Then we must leave a space of approximately 1.5 millimeter between an outline and the extension line, and the extension line must extend at least 3 millimeter beyond the last dimension line. And one dimension line and the second dimension line, if they are parallel to each other, they should be separated by minimum distance of approximately 10 millimeter. So wherever the parallel dimensions are there, they should be separated by approximately 10 millimeter. So usually you see, we should mention the dimensions alongside the object. So avoid placing the dimensions inside of the view, because inside of the view we want to describe the actual shape of the object. So the dimensions, it is better if we can mark them outside the object, so that would be better. It will make our view more and more clear, and we will have more space within the view to understand about technical details regarding shape and size of the object. Similarly, the extension lines, they can cross each other. Just see, the extension lines, they can cross each other, but extension lines, they should not cross the dimension lines over there. So extension lines and dimension lines, they should not cross each other. So this is the wrong way of putting down the dimensions onto the drawing sheet. Whereas if necessary, extension lines, they can cross each other, but they should not intersect with the dimension line. So here we can see that in the second case, that the same dimension, if it is repeated number of times, so we can use a general note. So this we have discussed, we can put down a leader line over here. So here you can see a component in which there are repetitive feature. So 4 holes are to be drilled having same size and dimension. So we are putting down this note over there using a leader line. 4 holes of diameter so and so are to be drilled over here. So by putting down the dimension only once, I have been able to label all the 4 parts of my drawings. 4 segments of the drawing, they have been attached to, they have been attended to. Now using the symbols in the dimensioning, as we have discussed, number of symbols, they are to be added onto the engineering drawing to describe the shape features of the engineering construction. So let us see, you have a component where some radial construction has to be made, some circular construction is there. So we have to mark down the center of the circle, and then depending upon the radius, we have to mark down the radius from the center, and then this radius will describe the construction of the circular portion. Similarly, this is again the radius. So in order to develop this segment of the portion of the component, this will be the radius, and I have to mark down with the prefix R. This is the symbol which will be required. So any radius
radial component, part of the component will be described by a prefix R. So capital R will describe the radius of an arc. Next, the diameter of a circular section will be represented by prefix phi. So wherever you see the circular dimensions are there, so we are going to mention prefix of phi besides the numeral value of the dimension. So 150 is the diameter. So this diameter will be indicated using the symbol phi over here. Similarly, if there is some spherical construction, at that point, in case of spherical radius, I can mark this particular symbol as spherical S. R is the radius. So SR 60 means that the radius of this particular spherical top of the component is 60 millimeter. Similarly over here, this is a sphere. Once again, a spherical dome is there. So for this spherical dome, S phi 50. So this is the diameter. SR stands for the radius. S phi stands for the diameter. Next, you have the square features. In order to represent square features, I can add the symbol square. So I need not mark this 30 here and 30 here. It would have led to redundancy in the technical drawing. So two dimensions should not be marked, where you can do away with marking it only once. So here you can see I can mark it using symbol square, or even I can write down SQ. So SQ is the square. So if I have the space within the drawing, I can do the dimensioning within the drawing. If I don't have the space here, I can use the leader line to indicate the square shape. Next, whenever angles are to be measured, so angles should be measured in degrees. So we should draw one line corresponding to this, another locus line I can draw corresponding to the other surface. Then I can mark these arrows, and the included angle I can show. If the angle is more, so I can show the angle dimension with two arrows on this side as well. So angular dimension can be shown with two arrows if the space is more. If the space is less, I can mark the arrows from outside, and inside I can write down this particular dimension over there. So this way, different symbols can be used to provide us with the detailing regarding the dimensioning onto the technical drawing. So this was all about the discussion regarding the basics of dimensioning in the engineering drawing. So thank you very much. Thanks a lot.